In this video, we are going to explore more about truck manufacturing plant. This video will focus on Isuzu manufacturing factory. Isuzu Motors Limited is a Japanese commercial vehicle and diesel engine manufacturing company headquartered in Tokyo. Its principal activity is the production, marketing, and sale of Isuzu commercial vehicles and diesel engines. Isuzu has assembly and manufacturing plants in Fujisawa, which has been there since the company was founded under earlier names, as well as in the Tochigi and Hokkaido prefectures. Isuzu branded vehicles are sold in most commercial markets worldwide. Isuzu's primary market focuses on commercial diesel-powered truck, buses, and construction, while their Japanese competitor Yanmar focuses on commercial-level power plants and generators. The manufacturing process. Heavy-duty trucks are assembled from component parts. Each truck manufacturer usually builds its own cabs, and a few also build their own engines, transmissions, axles, and other major components. In most cases, however, the major components and many of the other components are built by other companies and are shipped to the truck assembly plant. In most plants, the trucks move along an assembly line as components are added by different groups of workers at successive workstations. The truck starts with a frame assembly that acts as the backbone of the truck and finishes with the completed, fully operational vehicle being driven off the end of the assembly line under its own power. Today's most recognized form of heavy-duty truck, the tractor-trailer or semi-truck, was commercially developed in the 1910s. Some truck designers believed tractors, motor trucks designed only to pull separable trailers, could make truck operation profitable. If tractors easily connected to trailers, the more costly motorized tractors could remain busy hauling full trailers, while leaving less expensive trailers idle during loading or unloading. In 1911, truck designer Charles Martin built a gasoline-powered tractor to pull modified horse-drawn commercial wagons. His most significant innovation, however, was the fifth-wheel coupler. A round plate with a central hole, it attached to the top of tractor frames to connect and support trailers. Buyers converted wagons into semi-trailers by raising them with jacks and removing their front axles. Lowering and locking a trailer's bottom-mounted kingpin into a tractor's fifth wheel coupled the vehicles. Martin's rocking fifth wheel handled the period's rough roads. It allowed tractor trailers to bend when turning, but also accommodated the ups and downs of uneven surfaces. Nearly every truck manufacturer purchased Martin's popular device. Assembling the frame. A pair of frame rails are selected from stock lengths of C-channel. They are laid side by side and fed through an automatic drilling machine or punch to make holes for connecting crossmember brackets, engine mounts, and other frame-mounted components. A computer tells the machine the size and location of the required holes along the length of the frame rails. Small threaded studs are spot welded inside the C-section of the frame rails. The air lines for the brakes and the electrical wires for the lights and sensors are placed inside the frame rails and are secured with rubber cushioned clamps fastened to the studs. The brackets for the frame crossmembers are bolted in place using high-strength bolts or self-clinching fasteners. The left and right frame rails are then positioned opposite each other and the crossmembers are added. The frame now resembles a long ladder with the rails as the sides and the crossmembers as the rungs. Other frame-mounted components such as engine mounts, suspension brackets, and air tanks are bolted in place. Installing the axles and suspensions. The front and rear axles are fitted with the proper hubs, the round ends to which the wheels are attached, brakes, and brake drums. The axles are clamped to the suspensions by means of long U-bolts. Some suspensions use long leaf springs, while others use inflated rubber airbags. The front and rear axles and suspensions are lifted into place and attached to the suspension brackets on the frame. The shock absorbers are attached between the axles and the frame. Finishing the frame. Up until this point the frame assembly is usually moved from station to station either manually or with overhead hoists. The frame is now placed on a movable support and begins moving down the assembly line. The air tanks and brake chambers are connected to the air lines, and the lights and sensors are connected to the proper wires. If the vehicle is to be a tractor, the fifth wheel is lifted onto the frame and bolted into place. From this point on the frame assembly with the axles, suspensions, and frame-mounted components is referred to as the chassis. Painting the chassis. All components that are not to be painted are covered with masking tape or paper. The chassis then moves into a paint booth where it is painted with compressed air spray guns. Most truck manufacturers require that all component parts be received with a primer coat of paint, so priming is not necessary. After the chassis has been thoroughly painted and visually checked, it moves into a drying oven where a flow of hot air dries the paint. As it emerges from the oven, the masking tape and paper are removed. Installing the engine and transmission. The engine and transmission are brought into the plant alongside the assembly line. Almost all trucks now use diesel engines. The clutch is installed and the transmission is bolted onto the rear of the engine. The fan, alienator, and other engine components are installed and connected with hoses and electrical wiring. The finished engine/transmission package is then hoisted using lifting eyes that are part of the engine and is lowered onto the engine mounts in the chassis where it is bolted in place. The radiator assembly is bolted onto its brackets ahead of the engine. The fuel lines, air hoses, starter cables and coolant hoses are connected to the engine. Finishing the chassis. The fuel tanks are secured to their frame brackets and connected to the fuel lines. Batteries are secured in the battery box but are not connected to prevent accidental sparking. Aluminum wheels are left natural or may be polished. Steel wheels are painted before the tires are mounted. The tires and wheels are mounted on the axle hubs and the lug nuts are tightened. At this point, the truck is taken off its movable supports and sits on its own tires. Assembling the cob, hood and sleeper. The cab and sleeper substructures are welded or fastened together in jigs to hold the pieces in place. The substructures give the cab and sleeper their strength and provides fastening points for the outer skin and the inner upholstery and trim. The outer skin pieces are welded or fastened in place. This includes the sides, back, floor and roof pieces. The joints between pieces are overlapped and sealed to prevent leaks. The cab and sleeper doors are secured to the hinges. The hood is usually a molded plastic piece and is shipped to the plant without any hardware attached. The hood is checked for rough surfaces and is sanded as required. Painting the cab, hood and sleeper. The cab, hood and sleeper for each truck are painted at the same time. The surfaces are cleaned and the areas that are not to be painted are masked off with paper or tape. If a paint design such as a different color stripe is specified, the stripe area is painted first, then the stripe is masked off and the main body color is applied on a second pass through the paint booth. After each pass, the cab, hood and sleeper go through a drying oven. After the final pass, the masking is removed and the paint is visually inspected. Finishing the cab, hood and sleeper. The grille, headlight brackets, hood hinges and latches and the manufacturer's emblem or name are installed on the hood. The finished hood is then stored alongside the assembly line. The exterior components of the cab and sleeper, the grab handles, mirrors, visors, etc., are mounted before any work on the interior begins. The instrument panel is attached to the dashboard. The steering wheel, which had been left out to give working room in the cab, is now installed and the batteries are connected. The completed truck is then driven off the end of the assembly line, aligning the front and rear axles. To make sure that the front and rear axles are parallel to each other and perpendicular to the center line of the frame, the truck is placed on a laser alignment machine and the axle positions are adjusted as required. The angle of the wheels is also adjusted. This ensures that the truck will handle properly and have satisfactory tire life. Testing the completed truck. The truck is driven onto a dynamometer and secured with chains. The rear wheels of the truck sit on rollers set into the ground and connected to the dynamometer. As the truck engine spins the rear wheels on the rollers, the dynamometer measures the engine power to ensure it is operating correctly.